In the world of cybersecurity, we've pretty much always seen AI as this tireless analyst, right? A kind of digital bloodhound, sniffing out threats. But what happens when that bloodhound learns to bite? Well, today, we're looking at a brand new reality where AI isn't just thinking anymore, it's doing.
And that's the big question that's completely rewriting the rules of the game. I mean, just imagine giving your security software not just a list of suspicious stuff to watch for, but the actual authority to launch its own counter-operations. That level of autonomy? It changes the entire battlefield for attackers and defenders alike.
To really get our heads around this huge leap, we need to look at a system called HexStrike. It's pretty much the perfect blueprint for understanding how AI goes from being this passive advisor to a very active agent out in the digital world.
All right, so here's our game plan. We'll kick things off with the why, this big shift from thinking to doing. Then we're going to roll up our sleeves and take apart the 3 core components of this technology. We'll see how they all connect to form an autonomous loop, understand the new kind of threat this creates, and finally, really get why being aware of this evolution is just absolutely critical.
So let's zoom in on this core idea for a second. For decades, AI in security has been kind of like a silent librarian, right? Meticulously cataloging every little event and flagging anything that seems out of place. It's been an invaluable resource for sure, but it never left the library. Well, now we're seeing the librarian walk right out the front door, ready to take action based on everything it knows. The AI itself is becoming the operator.
To really get how this works, we need to pop the hood on this new engine. Now, at first glance, it might seem a little complex, but you'll see it's built from just 3 fundamental parts. Let's break them down, one by one.
First up, we've got the large language model, or LLM. This is the brain of the whole operation. It can process millions of data points from a network, understand the context, and then come up with a multi-step plan to achieve a goal. But here's the catch. On its own, it's all thought and no action. It's a brilliant strategist with no soldiers to command.
And that brings us to the second piece, the Model Context Protocol, or MCP. If the LLM is the brain, you can think of MCP as the universal translator. It takes the LLM's complex, kind of human-like reasoning and converts it into a crystal-clear, unambiguous command that a machine can execute without a single moment of hesitation.
Just think about the difference here. On one side, you've got explanation. The context and reasoning a human analyst might give. On the other side, you have a direct instruction. MCP isn't offering a suggestion, it's issuing a command. Do this. And this is the critical bridge that connects thought to action.
And that command gets sent to our third piece, HexStrike. This is the executor. These are the hands of the operation. HexStrike takes that clear instruction from MCP and actually carries it out in a live environment. Then, and this is so important, it gathers the results of that action. What happened, what worked, what failed, and it reports that intelligence right back.
This distinction is everything. Without an executor like HexStrike, the LLM is just a brilliant strategist trapped in an ivory tower. All its plans are purely theoretical. But with HexStrike, those plans hit the real world. They become actions, and those actions generate feedback. That feedback loop, well, that's the engine of true learning and adaptation.
So, we've got the brain, the communicator, and the hands. On their own, they're pretty powerful. But when you connect them, you don't just get a smarter tool. Nope, you get something fundamentally different, an autonomous loop.
This is what we call Operate Mode, and it's a relentless cycle of improvement. The LLM analyzes the situation and plans its move. MCP translates that plan into a concrete action for HexStrike to execute. HexStrike performs the action and observes what actually happens in the real world. That outcome is then fed right back to the LLM, which adapts its understanding and plans its next move based on this new information. Analyze, act, observe, adapt. Over and over and over again. And that loop is the real game changer. It transforms the AI from a simple chatbot that gives you one-off answers into a dynamic, autonomous operator. It's in a constant conversation with its environment, learning and evolving a strategy with every single turn of that cycle.
Okay, so what are the real-world implications of this technology? I mean, this autonomous capability isn't just some small, incremental improvement. It represents an entirely new class of threat that cybersecurity defenders have to confront right now.
Let's look at what makes this so dangerous. First, the decision-making is automated and adaptive. This is not some predictable virus following a script. It's a system that actively changes its tactics based on the defenses it runs into. It operates with the speed and persistence of a machine. It never sleeps, it never gets tired, and it can keep an attack going for weeks without a break.
This automation also means less human visibility. There are no clumsy manual commands for defenders to spot, just a quiet, efficient series of actions. And if one attack path gets blocked, it can instantly pivot to another, testing defenses in ways a human might never even think of. And, maybe the most concerning thing, this lowers the barrier to entry. You don't need a team of elite hackers anymore. The sophistication is baked right into the AI itself.
So facing this new reality requires a huge shift in our defensive thinking. We're moving beyond defending against static, predictable tools. We are now in an era where we have to defend against intelligent, autonomous agents.
So what does this new defensive mindset actually look like? Well, it means preparing for AI systems that don't just analyze, but actively act on your network. It means you have to anticipate threats that can evolve their entire nature right in the middle of an attack, making old-school defenses pretty much useless. And critically, it means figuring out how to detect and disrupt the continuous feedback loops that make these systems so powerful and so darn unpredictable.
As one expert put it, the future of cybersecurity will depend not only on defending against tools, but against systems that can plan, act, and adapt on their own. That, right there, is the new reality we all face.
And that leaves us with the critical question we all need to start thinking about. I mean, our tools, our tactics, our entire defensive playbook, it was all designed for a world of human-driven attacks. So how do you defend against a threat that thinks for itself?